Hello and welcome to the Digital Construction Skills Podcast. My name is Chris Grant, Partnerships Manager here at Digital Construction Skills. Today I'm joined by Fil Ntagadakis from Scotia Survey and Safety, and we're here to talk today specifically about surveying and reality capture and its use and applications from the perspective of an M&E or a building services and fit out viewpoint. So we'll explain what the most useful digital tools are for this sector and how to get started. So Phil, you're very welcome. How are you doing?
Really well. How are you, Chris?
Good. Not too bad, Phil. Good to see you. Phil, shall we begin by briefly telling people who you are and what you do and what your background is?
I'm currently Director and Reality Capture Specialist for Scotia Survey and Safety. A company started about a little over a year ago, and main goal is to promote the new technologies in the survey, construction, and pretty much any industry that can benefit from these tools, from dimension control to utilities to pretty much all sorts of different sectors. I've been in the industry since a little over 15 years now. Started with the survey industry, but at the moment, new technologies, drones, laser scanners caught my eye. I thought that these are, the potential is huge, and it's going to be beneficial to so many people. So this has been my focus over the last few years.
Great. So you're just the man we need to be speaking to about this, definitely. So before we go to speak about the digital tools available and what they can do, can I begin just by asking you, what do we mean by reality capture, and why would SMEs or contractors in the building services and fit out sector, why would they even bother with using survey and reality capture tools in the first place? Are they not just for site engineers and surveyors and tier one contractors?
Reality capture is, put it very plainly, getting the real world in a digital format. And because everything that we do nowadays is done in the digital world, be that a tablet, a phone, a computer, transferring information through the cloud to emails to different people, different areas, different parts of the globe, just to talk about changes on a specific project. Reality capture is literally that. It's the option to make a full digital representation of the real world that we can use for everything from planning to design to advertising to, I can go on for hours on uses. And just speaking to the second point, is it not just like, surveyors and highly trained people that can use this technology? No, every single person, to be honest, anyone from the age of 8 that has currently a phone is doing that. They're capturing the real world and putting it in a digital format. So the use of that equipment is easy. Further down our conversation, you'll see that the tools that we're going to be talking about are being controlled by something that it's nowadays embedded to our hands, our phones. So most of the instruments nowadays are being controlled easily by apps or available on Android or iOS devices. So it's very easy to control, and it's definitely not targeted to a specific sector or a specific user, and especially looking at the deliverables that you get out of them, that they offer so much benefit to all sorts of sectors. A surveyor will use it for literally carry out a survey in seconds instead of hours, but then a small housing construction company will use it to see the status of the build. The marketing company can see it for presentation purposes and fitting. Again, there's so many applications and so many people that can use them.
Great. That's setting the scene very well and for the next couple of questions then. So, well, why don't we just begin at the very beginning? You mentioned that this thing that's welded to our hands these days, the camera and the camera phone. So maybe we will start then with cameras and the camera phone. Can you take us through the basics then, and maybe onto the more advanced, the advanced camera technology that's out there? How can it be used, in the context of building services and fit out? And what else becomes possible as a result of using it? And maybe just give people an idea, as you take us through the stages, the range of cost for the hardware, because I think that's maybe another myth we need to bust about the cost of these things as well,
And a basic introduction to using these technologies to benefit and get the 3D documentation of our real world can be literally down to the basics of a camera, or as you said, a camera on a phone, because especially on a phone, they are combined with all sorts of sensors, the inclinometer, the little tilt sensor, which is practically inside your phone. And there is even free applications now that you can use on your phone to measure a height, a distance, literally just by using your phone and pointing from one corner to the other. You see the distance. It's not going to be to the millimeter, but it will give you an understanding of space. So talking about cost, just the fact that it's something that everyone has at least one of these phones with them at all times, and the apps that use these features are free to begin with, it means that literally anyone has access to those, and we can go into detail on specific versions of them. And if we take them to a step further, because what technically reality capture is to make a 3D representation, 3D document of the real world. To do that, we take it back to a technique which is being used for decades now, which is photogrammetry. Photogrammetry, to put it simply, is taking a series of photographs of an object, but using the angle of the camera and understanding the perspective of the object. It is then possible for the software to create a 3D survey, a 3D exact model of our object. And for that, we can do it with any type of camera. The better the camera, the better the results. And yes, I know I mentioned it's free to get into it, but if people would like to get a little more involved and get into higher resolution cameras and better phones, yes, they will get additional benefits. To take it a step further, we have drones that can capture these, that can move these cameras to locations that we cannot access, go over buildings, go surround buildings, go in areas where it's hazardous for a person to walk. So that takes it an extra step, where you get all these beautiful images, but from angles that you wouldn't possibly have access. And to take it an extra step is laser scanning, which is the feature of not only taking a picture, but using laser distance measurement, we can get these points recorded down to the millimeter. I know laser scanning, to someone who hasn't used that technology or hasn't heard the technology, may sound a bit intimidating, but it's extremely easy on getting from, again, a real world object, structure, building, person, to a digital format.
Right then, so what can you maybe give us a couple of case studies then or just some examples then of just someone in the building services sector using a camera for measurement? What could they use it for? Are you saying it would just take away from the pen and paper type of thing? Is that in the most basic, simplest form?
It is, and it actually is quicker. Some people will say, I just can take a tape and a piece of paper and do each room and measure. And I can be done in a room in less than a minute. A scan of that room can take less than 20 seconds, because it's if you only need a basic layout of the room. If you want to take pictures, again, by the time you record 4 pictures or even just record a video on that room, you have all the information that you need. And again, using specific bits of technology, then a very quick house survey, building survey, can be completed in literally the time it will take you to walk around that home. There's no chance any other tool, even the basic pen and paper and measuring tape, that will be as quick, and it will definitely not be as accurate, because if you plan on measuring every window, every door frame, the ceiling and the flatness of every wall, you could spend ages there, even with not only steel tape, but if you use traditional surveying techniques like a total station or an optical instrument, that would take ages, whereas this new technology, by using photogrammetry, using a combination of sensors, can do that literally in minutes.
So effectively, you could have that data and a laser scan, send it to your estimator, and back in the office, without even being back in the office yourself personally, you can just send it straight to them. They've got an accurate representation of the model if they're, say, estimating for surfaces and interior, and it would just give you that one version of the truth, if you like, and I guess it would eliminate a lot of errors as well. Then if you're taking it from an instrument like that.
That is correct, and especially now with the increase of 4G and 5G coverage everywhere, the amount of data that can be transferred is amazing. In literally seconds, if not minutes, you can send a full laser scan of a building with a 5G connection to your designers, to another team, literally in any part of the planet, and they can just get back to you with requirements for anything. And again, we can be here in Scotland just doing a project, and there's a company down in Wales or England that will be doing the work for us, and it can literally be, as you say, we finished looking at the site. By the time we're back at our office, they have already seen the data, processed the data, made their changes, send them back to us, and technically we can save hours and hours and hours of measuring, and also we will save thousands of pounds on fuel and petrol, which, yeah, it's kind of hard thing to find, especially these days. And the fact that you just get one person there to carry out all the work, and they have captured everything. It's literally from power socket locations to fire alarms to every bit of information on that structure or that building is recorded. No one has to go there and revisit.
So does this data then, are you able then just to export that to say, a lot of people now use work with BIM, obviously, or it's becoming more, people are looking to adopt BIM, or they need to be using BIM on maybe the bigger projects just now, but certainly it's a good method of doing it. But this can be compatible with like a 3D model. You can export that, and can you overlay that then on the model to check, say, as-built positions and things like that? Is that the other thing? You can just check the accuracy of the information of the model has been given to you, and just check that your scope's correct, and you've got the measurements right and the estimates right, and it kind of eliminates a lot of errors as well. Would that be correct? How does that work? Maybe tell us a wee bit how that would work.
It's exactly that. So once you have the basic output of a laser scan survey, or a drone photogrammetry, or even a terrestrial photogrammetry survey dataset, which is a point cloud. It's a cloud of information, that it's a 3D cloud of information. That bit of information, as you say, again, as I said, the same type of information can be used on all sorts of different sectors. So, for example, in shipbuilding, they can take a full scan of a vessel against its design and see a dimension control paradigm. Same with a structure, a home. You have perfectly designed it in a CAD suite and like Revit, and every wall is 90 degrees and everything looks fine, but straight away you can do a laser scan of that same room, place the two together, and you can run literally a collision detection or a verticality report or pretty much everything, and see how the flatness report on floors, ceilings, walls, everything. These are automated processes, so you don't even have to spend hours and hours of doing that. So once the scan data is available, you can compare to the design work. Also, if you do have the scan data, you don't need to create a model of that house. So if you want to add an extra room, or if you want to remove a roof and see how it will look with different types of windows, or literally anything can now be applied in situ, so you can see exactly how it will look and how it will change the whole apartment. You can even take it a step further and simulate sun access on specific times of the year and specific time of day to see if you build a window there, will you maximize the amount of light that gets into the house, or would it be better to put it there because our neighbor across the street has a new tree which kind of blocks access? You can get all that information and you can simulate literally any kind of scenario.
Brilliant, Phil. Well, let's go on then to talk maybe a wee bit more into the drones then. So they're becoming more widely used, and you can see a lot of benefits that we see in maybe the civils and infrastructure sector, particularly related to get much better reality capture and for faster, more accurate surveys we've talked about already. It can be used for stuff like remote inspections of roofs, reduction of health and safety and working at height and all that kind of thing. So, but what about building services and finishing sector? Can they utilise drone technology, in a building? What would that look like? Can you use it inside buildings as well? It's not just for like roof inspections, is it?
That is correct. You can use them anywhere, indoors or outdoors. And the amazing thing with drones is they are progressing literally at the paces that phones were progressing. So we started with basic single color phones about 2 decades ago, and now we're talking with about phones that can literally fold and do anything we want. Same with drones. They started as a basic hobby for some people, but in the last few years the developments have been huge. So even using them indoors or underground or literally anywhere you want, it's now much easier, and it makes things a lot safer. You want to check anything on a house. Currently, all the buildings, services and finishes sector will most likely walk around with, again, pen and paper, take a picture, take some information about the house. But again, you can send a drone now. They can get automated. They have all these sensors, so they can go through each and every room without fear of any collision or any issues whatsoever. And you can use all sorts of different sensors. You can use cameras, normal cameras, which will capture every bit of detail on every corner of that structure. But also you can have thermal imagery, you can have multispectral imagery in case you want to check specific types of conditions. Literally, the use of drones is getting better and better by the day.
So is it, you're saying about getting hard to access, so take it like confined spaces or even just hard to reach, where you maybe can't get up with a scaffold, or you don't need to build a scaffold because if it's just purely for inspection and not doing any work, and how does it work, in terms of piloting one of these things, is it difficult, or is it all pre-programmable, and how do they move about? Just maybe talk us about how you'd fly a drone, say in an internal inspection. How would you go about doing that?
3 ways. The easiest way of all is a completely caged drone, where, put it simply, there is a full cage surrounding that drone that will allow you to pretty much bounce off the walls. Even if you have 0 skills, you can just take it. And this is amazing, especially if you're doing underground surveys. You want to send it down a manhole without having to send a person down there. Then literally you just send one of these things. It's very easy because practically the way it transfers the image to the pilot, the user, you feel that you're actually walking into that room, and you can look left, look right. So it's really common when doing a survey like that or inspection like that. People will be looking on the screen, they'll say, oh, can you look to the left? They will not say, fly the drone to the left. It's literally, can you look to your left? Can you look to the right? Can you look up? And this is what you do. This is literally what you do with the drone. You will look left, look right. There is other drones that have all sorts of sensors, up, down, left, right, front, back, which will literally stop them from getting close to a wall and get smashed. But not only these sensors will help on not crashing them, but also if you want to prepare a consistent photogrammetric survey of a surface and you want that drone to stay at 50 centimeters away from that wall, it'll do exactly that. So it will fly, it'll stop exactly there, and you can just push forward as much as you want. It will not do it. The third method, which is a lot more fun, you can get amazing detail, but it's a little more risky, and it does require a bit of experience in flying them, is manual mode, where literally you have full control. There is a risk of crashing, but with experience in talking to other pilots, I have seen that in certain scenarios, it's much easier to just take full manual control. And honestly, I'm not talking about hours and hours and hours and hours and hours of practice. It's literally any person that can commit a few days on practice. I have seen huge leaps on skills, so they can do amazing things. Some people get it much quicker, some take a little longer, but I haven't seen a single person that cannot operate a drone.
Wow. Okay. Well, that's quite in depth. So maybe just before we wrap up the kind of drone section, then, what are we talking about here in terms of getting started with drone? Is it a cheap technology? Obviously there's very sophisticated ones, but maybe you can take us kind of the range, of typical range that would be used maybe in the construction industry just now.
Before getting into an industry, I would say that it's ideal for anyone that even has an idea of getting into drones. Get one from any high street retailer or literally any shop. There is drones available from 10, 15, 20 pounds. They're not to be used for survey inspection or anything like that, but they're an amazing training tool, and it will help anyone that plans on getting into the sector. In order then to take it actually on professional use, most people can find a second-hand previous or couple generations back drone at the moment for less than £300. A current model will be usually between the £500 and £1,500, depending again how many batteries you want, what type of cameras it has, and everything. And then it's just a matter of specific requirements. For a drone usually of the £700 range to 1,000 would cover 9 out of 10 projects with absolute ease. Wow. If we go into particular projects and difficulties, yes, there are more expensive drones that will do things quicker and easier, but that doesn't mean that the cheaper drone will not do it. It may take a bit longer, it may require a little more skills, but the result will be similar.
Okay. All right, then. So, what about training then? So, how do you train to become a drone pilot, if you like? What is the range? What can you do? So, say you're go to buy someone at a shop. Obviously, different to somebody who's piloting a drone near, doing a survey near an airport. So,
there is legislation. The CAA still governs the use of drones in the UK. Things since last December have been a lot easier, because previously, in order to operate commercially a drone, it was a completely different process, but it has changed. It has become a lot cheaper. The key thing, no matter which type of license or certificate or that you get is to get some experience. This is what any NQE, any national qualified entity that offers these certificates for flying a drone commercially or practically for anyone that wants to use it for anything other than just a hobby, they will ask for your flight logs, your flight records. This is why I said if you're even vaguely considering getting into drones, get a cheap drone to start building up your piloting skills. This is what it's always needed. The funny thing is that the cheaper the drone, the more difficult it is to operate. So the more money you spend, you'll find that the drone literally flies itself. It still requires, or it doesn't require, but I always advise that whoever is going to be the pilot of the drone knows how to fly it manually in case everything goes wrong and all the sensors fail, then, which I've never seen, to be honest, but it's always nice to know that if everything fails, I know how to pilot the drone and how to take it forward and back and bring it down on the ground safely.
Okay, then. So just to finish off the training part, then. So just to get this in my head, then, I'm a working in the interior sector. Or a contractor, and I want to use a drone. And I've got to go on site. I've got to write a risk assessment, all the rest of it. What are the kind of things that a project manager or a tier one contractor would want from you in terms of to see your training and qualifications and how you use it safely? As maybe just the kind of headlines, if you like. What are the key things?
Key thing is being professional in your approach. So if you have all your appropriate certifications for flying the drone, you have your flyer ID, which is something the CAA will request, and also you have your procedures in place. You need your flight reference cards, the same principle like an airplane pilot has, where they have their flight reference cards and they need to tick every bit of data. So is the propellers on the airplane, is the propellers on the drone, is the batteries, are the batteries in good condition? It's pretty much, this is what is always requested, and then it's just a matter of going through your method statement and your risk assessment, which again, going through the courses that I mentioned earlier on getting your certification is something that everyone will cover, because again, this is the key thing. I wouldn't, from experience, I've seen that the key thing is a professional approach. If you're, for what you plan on doing, you're clear, you're thorough, and you have made sure that you covered every single angle, then this is it. This is what I've been trying to promote on our training courses, which is the concept of being professional, the concept of making sure that you have every situation covered.